All right, when you're asked to find the sum of the first n terms of an arithmetic sequence, they're going to give this to you in two different ways. They're going to give you a set of numbers, and you can see there's a group of them missing. But they want you to basically, you could add all these up. You could find the missing numbers and add them all up. But I recommend that you don't do that. That might take an awful long time. Instead, go ahead and use this formula. And this formula only works for arithmetic sequences. So if you want to find the sum of 50 terms, you'd take the sum of n would be 50. And so you'd replace here, 50 here. And you'd need to take your first term and your last term and divide that by 2. And that would give you the sum of all the numbers. Now sometimes, like here, you can see I have my first term and my last term, but I don't know what n is. So I don't know how many terms there are. So what you're going to do is you're going to use one of these other formulas here. So this is the formula we used earlier, and it's just been adjusted because if you know the first term, then you could just make this a sub 1, and you make your m 1 here. Okay, and so you're just going to use this formula here to find out what n is, and then plug it into this formula. Okay, so let's go ahead and do that for this first problem here, A. So we need to find out what n is. So we know what a sub n is. A sub n is 438. That's our last value here. We want to know what the n value is for that last term. Okay, so a sub 1 is 8 plus, okay, what is n? We don't know. That's what we're looking for. And what's d? Well, they didn't give us d, but it's here. And so remember, d is the common difference. So it's the difference between these. And so you can take the number like here, 13, and subtract 8. And you can see that that's going to give you 5. You could do the same thing here. If I did 18 minus 13, I get 5 as well. Okay, so we see that d is 5. So we're going to replace d in this formula with 5. So we're basically using this formula. And now we can just solve this. I'm going to subtract 8 from both sides. And I'm just going to write this as 5 times n minus 1. It's going to be n minus 1. Okay, so now at this point you can go ahead and you could do a couple things. You could divide both sides by 5, or you could distribute the 5 through and solve the equation that way. I like to just divide it by 5. And so 430 divided by 5 gives me 86. But it will work out to the same thing either way. So now add 1 to both sides and you get 87 equals n. Okay, so that gives us n, so now we can plug this, we have everything we need for the sum formula. So the sum of the first 87 terms, that's how I think of this. If you notice, that's what I say when I write it down. I just don't do s of 87, I say what it means. That's going to equal n, which is 87, times the first term, which was 8, plus the 87th term, which is 438. And you divide all of that by 2. And so you're basically going to add 438 times, add 8 to that, and then times that by 87 and divide it by 2. And you're going to get, when you do that, $19,401. And that is the sum of the first 87 terms in this arithmetic sequence. Okay, now we're going to go down here to part B. Now you're probably looking at this. Some of you may never have seen this. This is sigma notation. Basically, this, when you see this, think, it's telling me to find the sum of the first term to the 131st term. That's what this means, starting at 1 and counting until you get to 131. So technically, if you're trying to find the first 1, 2, 3, 4, 5 or more terms, you would take 1 to plug it in to get your first term. You take 2 to plug in for j into this expression right here. Plug that in, multiply, add them together, and that will give you the second value in your sequence. You keep going, okay? So let's kind of just separate this off. So let's look at what we have here. So if I have this information, you know what n is. N is going to be 131. Okay, I can figure out what the first term and the last term are by plugging in 1 for j to find the first term and plug in 131 for j to find the second term. Okay, so let's see. So if j is 1, then I plug this in and I get a negative 3 times 1 plus 8. And that is basically going to give me a sub 1. Okay, so negative 3 plus 8, that's going to give me 5. So now what about when j is 131? So I want to find out what a to the 131st power is. So I plug that into that expression, negative 3 times j. But I'm going to replace j with a negative 131. Excuse me, positive 131. And I'm going to add 8. So you're going to multiply 131 times a negative 3 and add 8. And that is going to give you a negative 385. Okay, so now we have everything we need. We can plug this into the sum formula. So the sum of the first 131 terms in your sequence, we know it's an arithmetic sequence because they told us that, but you also could figure it out if you wanted to plug j in for 1, 2, and 3 and look at the pattern and see if it's an arithmetic pattern. Okay, so here we're going to get, let's see, so we're going back up to this formula right here. So we want n is the same number as here, so that's 131. We're going to multiply that by the first term, which we found was 8. We're going to add it to the last term, plus a negative 385. And we're going to divide that by 2. So we do our order of operations. We do the stuff inside the parentheses first. We add these together, times it by 131, divide it by 2, and you are going to get an answer of negative 24,890. And that is the sum of the first 131 terms of that arithmetic sequence.